Of Sakai. Switch to just to our little pretty looking slide of uPortal of Sakai, of Unicon services, what I was trying to say.
Go back.
We'll just spend like well, that's long enough. This is the stuff that we work on and supported. If you're interested in using or running any of this stuff, then please find one of us and we'll be happy to tell you about it. Obligated to show these kind of slides because of our generosity of our employer. A little bit about Bob and I. Basically, I've been working in Sakai for a while. I'm one of the software architects at Unicon. The shortish version is I'm sort of one of the longer-term active members of Sakai, I suppose. They're silly enough to stay around for years and years and years and years, but it's pretty cool, and I like the community, so I do. Bob's been involved since about 2006. Both of us started off in higher ed and then moved into commercial affiliates later. So if you want to swap war stories about higher ed stuff and planning committees and things of that kind of nature, happy to complain. So, so that's our quick background. So let's get into what you actually came here to hear about. Sakai scaling. So we've worked with a few very large universities and commercial, I'll just say, companies, for lack of a better way of saying it, who are using Sakai as sort of a core service and running it for very, very large scale. So online only, typically, so not sort of the blended learning model that probably a lot of universities are using, but rather the fully online model, which is to say students and teachers only interact virtually. There's not really a whole lot of face-to-face, if there is
like
any face-to-face.
no physical campus.
Yeah, often no physical campus at all. So when you're running that way, it's a little different than the blended learning because the load factors actually shift on you a bit. It's not so much just that you're going to have a quiz every now and then, and most of the students are just getting on there to grab a syllabus and maybe look up an assignment or two. It's really more that they're on there for their entire experience, and so some things that don't come out when you're just doing blended learning start hitting you a little bit harder when you're fully online like that. And also, of course, we run into some issues where we have million-plus users in a single installation, and at those kind of scales, with it being fully online, you're looking at loads where you can have as many as 100,000 concurrent users at peak times. It's really heavy, heavy loads. I don't expect most people here will experience that kind of concurrent load, but what it does do is it exacerbates certain problems. And we're going to talk about what some of those certain problems are. And I think this does apply even if you're a 20,000 user school and you just don't want to run 500 Sakai nodes, which is actually counterproductive, and we'll get into that. And if a few of you I happen to recognize are running, say 100,000 students and seeing probably concurrency around the 10,000, 20,000 range and stuff like that. And so, those kind of things will put really serious pressure on any server installation.
Yeah, even small instances, this stuff will actually help you.
Yeah.
It won't be to the order of magnitude that we'd see with 100,000 concurrent users, but
right.
even 5 or 10%, boost in performance could help you out there.
Yeah, exactly. So, all right. So a couple of the problems that we sort of recently have worked with, different groups, but similar solutions, and we've actually just had a recent sort of push to get all this stuff, or at least aspects of all this stuff, out into the community for Sakai 10. So most everything we're gonna show you and talk about today is either already in Sakai 10 or at least partly in Sakai 10. So the key bits are there, and some of the more specifics need to be built out. But I'll mention where those differences are. So the first bit, horizontal scaling, essentially what we mean by that is really what you want to get is every time you add a new node to your cluster, you want it to actually increase your load, increase your ability to handle load, right? You don't want it to be, I add one node, I get 100% increase, I add 2 nodes, I get a 50%, I add 3 nodes, I get a 25%. Unfortunately, in the pre some of these kind of patches world, you are looking at something which is what's the term I'm looking for?
Logarithmic.
Yeah, it is a logarithmic type curve. Diminishing returns, that's the phrase I was looking for. So Unfortunately, it just doesn't go up very linearly. I mean, you're never going to get perfectly linear, right? It's always going to be something like, okay, the first one is 100%, the second one's 99%, 98, 97, etc. But there's always going to be some loss for communication. But you want to be as close to that linear curve, as it were, as you can get, and as far away from sort of a rainbow curve, which is actually the kind of thing that you would see without some of these kind of changes. Eventually, you're going to see a bit of a rainbow curve where, as you add more nodes, you actually start decreasing your performance. You actually start hurting the performance of the system. So cluster caching, that essentially is a concept which I imagine everyone is familiar with, but something that Sakai, generally speaking, really doesn't have. And I say generally speaking because it's not 100% true, and I'll get into more detail on that. And then finally, redundant clustering, that is just the idea that we're in a sort of a cloud world these days, and a node should be thought of as disposable. Right? It should be possible to just say, okay, I need to take down those 3 nodes and just kill them, and the user should not really notice that that happened. Most of you probably know that is not the case in Sakai and 2.9.
Definitely.
So a high-level overview, and we'll get into a little more detail on each one of these. I wish I could actually see these slides better. I should rotate it slightly, because no, that'll be fine. So, wait, that's the one we're just at. Yeah. Next. All right, so horizontal scaling problem in more detail. Essentially, more nodes in the cluster right now. The problem is more nodes in the cluster means more traffic to the database. Essentially, the short version is that as you add every additional node in the cluster, it actually is doing a scan against the events table. If you've done any administration with Sakai, you know that the events table is truly massive, basically the most massive table in all of Sakai by an order of magnitude typically. So the more times that you're scanning that table, the worse your performance generally is going to be. So as you add every additional node has to keep scanning that table. Now there are ways to work around this, and typically what we've done in the past, with the, oh, sorry, calling me apparently. I don't, sorry about that, sorry, let me just vibrate my phone. Okay. Sort of spice it up a little bit. Essentially, the more nodes in the cluster, the worse it gets. And there are, like I said, there are ways to work around that. You can sort of cheat as it is by reducing the period for pinging the cluster, pinging the database. So typically, it used to be 3 seconds back in the olden days. These days, it's 5 seconds by default, and you can just back that off further and further. Now, the further off you back it, obviously, the less recent your event activity will be. So if someone does an event and you expect it to actually affect something on the other servers in a reasonable amount of time, the further that ping period is, the longer time is between those events. And you can't get into race conditions if it's too long, right? And I'll talk about that in a minute, or a few minutes actually.
Yeah, especially with like roles and things like that.
Yeah, exactly.
Roles, which are based off of events, which, it's like you change the permissions on one thing, it's got to propagate through all Tomcats.
Right. Yeah. And you can actually get into a weird race condition where by the time it propagates, something else has tried to do something different, and then race conditions are always fun. So you want that race condition to not be horrible, but unfortunately, in order to avoid beating your database to death, you either have, I guess you have another solution, which is just to buy the biggest database you can possibly buy, and that's what most clients, generally speaking, tend to do when they're in this situation. Just throw a heck of a lot of iron at it. But I think that there are limits to that. We've certainly run into those limits. In fact, part of the reason for some of this work is we ran into those limits on AWS with the clients that are running the 1 million+ users, where we're using the biggest possible database instance AWS has. We've even got multiple, master-slave type configuration, and it still was just too much. Database couldn't keep up. So the solution is to essentially start moving data, or actually the solution is the next slide. Sorry, we have a pretty picture to help illustrate, actually. It says, words are boring. So the red actually, which is, it's a little bit hard to read, but the red arrows are reads to the database. So we're kind of showing that read load is fairly intense. And then the writes essentially, so there's reads and writes, but the reads get to be fairly intensive because it's just going out, like continuously asking for data. Every single one of these nodes is asking for data. So the more nodes you get, the more red arrows you get, eventually it's just ridiculous beating on the database. Writes actually aren't so bad, especially we did some profiling on this and found that generally speaking, the writes are not a big deal except for when the reads are waiting on the writes, right? So essentially, if there are a lot of writes happening but no reads, then the load on the database is virtually undetectable, right? But if there's lots of reads and lots of writes, then you start getting into a bit of locking situation where you're writing the table, you're also asking for the reads and stuff, and it's like, hold on, I'm still writing, hold on, okay, here you go. It's not a huge wait period, but it does start building up, and when you get 30, 40, 50, 60 nodes, then that read-write wait period starts actually being punishing to the server. Okay, so what's the solution for this? So the solution that we came up with, which was our sort of what we thought was the best scenario as far as something we could push out to the community easily, didn't require a whole lot of additional configuration or additional servers, is this one here. This is in Sakai 10. It's just disabled by default, of course. So the idea is that events still go straight into the Sakai events table. Do we have a picture that shows that in a second? Yeah. Let's just skip to the pictures. That'll be more interesting.
I just have a general solution showing the distribution.
Yeah, no, that's perfect. I think this illustrates it better anyway. So the idea is that the writes are still all going into the database, just like they did before. Like I said, we profiled this, minimal load, almost undetectable, really. Even having many, many nodes writing into the same table, it just doesn't cause much of a problem because nobody's reading from it. So there's not really a whole lot of waiting. The only waiting is, oh, I need to write a bunch of stuff. Okay, let me just finish, done. And that's nanoseconds. It's just undetectable. However, all the reading is actually coming from the distributed Terracotta cluster. So the Terracotta cluster is actually having the same data written to the Terracotta cluster as written to the database. Terracotta cluster, of course, is all in memory, so that wait period that you might have had with the locking really doesn't happen in the Terracotta cluster. So then you read back from the Terracotta cluster all the events. So we move the load from the database onto the Terracotta cluster, and it doesn't have to be Terracotta. That's just the current implementation. We're going to be showing you Terracotta today, but technically speaking, you could swap in any distributed cache. So Redis, Hazelcast, you take your preferred pick. Anything will work. It's just that the current implementation is Terracotta based. So essentially, we shifted the load, and this is a typical cloud solution, right? I mean, I think if you're familiar with cloud architectures, this is a typical thing to shift loads around within the cloud to different services. So all we did was really just shifted the load from the database. Generally speaking, the load is actually, as you probably would guess, a teeny tiny bit higher on each one of these app servers. So we've actually increased the load just a fraction on every app server. However, by reducing the load on the database, which tends to be your bottleneck, we've actually increased the overall speed of the system. So,
do you want to go back to the previous?
No, I think we covered it. I think we covered it. Okay, so cluster caching. What's the problem with cluster caching? So Sakai has a general, basic, very, very basic concept of cluster caching. Basically, it uses events, right? And so there only was one cache, which actually, before we went and really dug into this last year, we actually thought there were two caches that actually took advantage of this. But once we dug into it, we found out there was actually just one. The one that actually does authorization groups. So I'll see group roles, which essentially just means security checks. So security checks and I'll see group role checks if you know the part inside of Sakai, but don't worry about it if you're not familiar with it. Essentially those checks, every time that you say, can a user do blah in a certain course, right? Do they have permission to do X and Y? That check will get cached, which means that anytime a role changes, you've got to flush that cache out, and you really need to propagate it out to the whole cluster. So the way that this would work in the old Sakai is it would send out an event, and that event would say, I just changed the role for so-and-so's user. And on every node in the cluster, it would then purge out that cache, which is fine. I mean, it's an invalidation process, so it's not ideal. I don't think we have a slide that talks about this later, do we, about invalidation versus replication? I don't think so. So the short version of why you care about invalidation versus replication in a caching scenario is that invalidation just says, hey, every cache out there that is on every server, just purge that data out of the cache, get rid of it. And so every node in the server, every node in your cluster will just burn that piece of the cache, which is fine. However, that data still has to be reloaded at some point. So if, let's just say it's a piece of data which is then needed again on every node in the cluster, then every node in the cluster will now smash your database saying, I need that data again, by the way. Hopefully that wouldn't be the scenario with AUC because you wouldn't have the same AUC checks likely on every server. So it's unlikely it would be as bad as the worst case scenario. However, it does put more load. Generally speaking, validation puts more load on the database than replication. So what we looked at here was how can we move some of this stuff from invalidation into potentially replication. So again, getting back to what Sakai does, when I say today, I'm always referring to 2.9. So what Sakai does in 2.9 is, again, sends out those events. So through that event mechanism, which we did improve the event mechanism by going through a Terracotta cluster, but we're still doing invalidation. Right? We're just saying, get rid of this, burn this other thing out of the cache, instead of actually just propagating that data out to everybody else in the node. So the problem with that is those individual caches on every single server tend to contain a lot of data, they use up a lot of memory, and they also have to burn the database because of that event processing. So it puts more load on the database. So again, the idea here is really, where is your single point of most load? The database. So how do we reduce that? Caching. But if the caching actually could cause slightly more load on the database in certain circumstances, then that's negative. So that's where we are with the current problems. So what's the cluster caching solution? To actually switch over to more of a replication type scenario. So take out that use of events to just invalidate and use true distributed caches. Again, something like Redis would work, something like Hazelcast, something like Grid, whatever, take your pick. But we did our implementation using Terracotta, and I'll talk a little bit about why we did Terracotta here at the end, probably later on near the end. But the short version is because EHCache is already there in Sakai, and so it was easier to use something compatible with EHCache. If you're not familiar with EHCache, don't worry about that. It's just the caching library used in Sakai. If you're not familiar with how EHCache and Terracotta connect together, the short version is that Terracotta is the distributed EHCache. So if you wanted to distribute EHCache, you would need a Terracotta server. That's the only reason why we selected it. Again, in the future, we would potentially want to move away from that, I think. Okay, so what else did I say here? Did I cover all this? I think I did. Oh, right. So we did want a solution where you could operate in exploration mode as well, because there are certain cases where data can't be replicated if it's just truly massive. You can run into this thing called a replication storm, which essentially just means that the data is so big, it takes so long to send around to all the nodes in the cluster, that it actually starts using up all your network traffic, using up too much bandwidth. So caches are only good if they actually reduce the load on the system. If you have a replication storm, it's actually worse. Okay, so the last of our three major problems that we're trying to solve is the redundant clustering. So essentially this idea that in a cloud-type world, Sakai nodes, we want them to be disposable. We want them to just be a commodity. You don't want your node to have to be something that has to live and has to survive for the lifetime of whatever, whatever updates or upgrades or whatever current version you're on until the next time you upgrade. That's really difficult for any system administrators. I'm sure that you guys are aware of those kinds of issues, but it's also just dangerous. It doesn't give you the ability to easily scale up and down. You can't just go, oh, well, today, we have sign in and sign up, and everybody's checking for their new syllabus because it's the first week of class. So we really want 10 nodes in our cluster, but when we get to the third week of class, we know we're going to drop our load by about half, so we'll drop down to just 5 nodes in the cluster. There's ways to do that. The easiest way to do that is to drop a server out of a load balance pool and just keep an eye on it and wait until everybody logs out, and then eventually you can kill it out of your pool. The problem is if you have a ton of load and you'd like to throw a bunch more servers into your pool, you're sort of in that same waiting game. And if you want to do something like a hot update, so essentially rolling out a new patch or rolling out a new feature, well, generally speaking, and this has certainly been the case when I worked at University of Cambridge and Virginia Tech, if we wanted to do an update of Sakai, we had to schedule 2 hours of downtime to take everything down, take all our nodes down, upgrade them, bring them all back up, and that's nasty. And we did try to do a couple hot installations where we would just wait for everything to die down on clusters and bring up a new cluster, but that actually can become a little bit tricky because if the user lands on the new node, but then it is sending events out to the old node, and the old nodes don't know what to do with it, or the old nodes are sending events to the new nodes, and they don't know what to do with them, then things get a little bit weird. So it kind of just depends on what you're actually upgrading. but we've run into some issues with that. So our idea is really that it'd be nice if we could just burn a node down, bring up a new node whenever we want to. And that's what this is meant to address. So this is kind of a different issue. It's scaling, but it's not just about performance. It's really more about the ability to treat Sakai more like a cloud-based service. So for those who aren't familiar, Sakai forever has needed sticky sessions, which is to say that if the user logs in, they have to stay on one server. If they actually popped over to another server, they would have to log in again because the session data is actually not shared between Sakai nodes in any way, shape, or form today. Again, today I mean 2.9. So the solution is to serialize the session and somehow transfer the session around, right? This is typical. This is nothing new. It's nothing particularly innovative in the world of servers and computing. I mean, gosh, this concept's been around since '95 probably, maybe '97, whatever. But it's been around for quite a while, right? So the idea is that really we needed to bring Sakai into the brave new world, quote unquote, of 2003. So it's bringing sort of the concepts forward was actually a lot harder than we thought it would be. We did this originally using Terracotta's object, crap, forgot the name now, object, shoot. The thing where you can share objects within the JVM, and they have a name for it, and I'm blanking on it. So our original solution was to do it that way, and we did it that way in 2007, and it has run along like that quite well. The problem we ran into with that in general is that it marries you to Terracotta. And for those who don't follow Terracotta's various comings and goings, they've had a little bit of a shakeup in their management and in their business model. And their free version isn't quite as good as it was before. I don't want to make anybody upset on the recording, but it is just a little bit crippled. So we don't want the community, the Sakai community, to have to be stuck to always using that. So we moved away from the object sharing in the JVM. That also actually was pretty serious. There's a general trade-off, about 30% performance hit in an individual node when you're running that way, which if you're a big client, you've got 60 or 70 nodes, well, you just throw a few more 10 nodes or so in there and it balances out. But that's not a great long-term solution. Plus, distributed caches have come a long way since 2007. Things like Hazelcast didn't even exist. They were like a glimmer in nobody's eye at that time. So there are much better ways of moving data around inside of a node or inside of a cluster of nodes rather than sharing objects. So what we did instead is we went with a solution that serialized the actual session itself. It is a little bit manual, right? There's some work you have to do. You have to decide, you have to make decisions in the code. What am I going to actually transfer between the different nodes? What has to be transferred? We did some interesting tricks, like if you have a user's, let's say a user's profile that's stored as part of the session, do you really need to send that profile out to all the other nodes, or can you actually just send the ID of the profile? And then if you ever need to rebuild that rebuild that session on another node, just take that profile ID, look it up. Now it does put a little bit of additional load on the database, but the general theory is that even if you have nodes dropping in and out, it's not going to happen all that often, whereas you are going to have to serialize the session virtually every time there's a request. Not every single time. We're able to put some fairly sneaky little rules in there to determine how often things are serialized and what is serialized, and those are configurable, generally speaking. But it's not just a matter of every single time we just take all the data in the session and dump it. That just beats the servers to death. So we went with sort of the idea that lots and lots of writes into the system, but only a few times rebuilding the session. But
can I ask a clarifying question? You keep using the word "you" in your thing about you have to send the profile ID over. I assume that what you mean when you say you mean Aaron had to do this and not code, versus every single system administrator who ever would run Sakai doesn't have to decide whether to send the profile or the profile ID.
That's right. Yeah, I'm sorry. You're correct. The decision, we sort of made those decisions in the code. It doesn't, I mean, it's open source, of course, so I'll always throw that out there that anybody can change it, but we did a fair bit of profiling, so you may want to just start off with our decisions and then you can always
It works. It's not like people have to figure this out.
Correct. Yeah. What we're going to show you is we're going to demo all this here in a minute, but what we're going to point out, it's all just a matter of configuration, right? You put in certain configuration settings, you put in certain Sakai property things, essentially. When I say configuration settings, that's what I mean. And it kind of works, assuming you have a Terracotta server. Again, that Terracotta server, right now, that's what you have to use because of the age cache connection. We did do some separate work, which I don't think we talked much about in this slide set, but there was a separate effort to essentially make Sakai JCache compatible. I'll just talk about that for like 2 seconds, because I think it's actually a major improvement. And if you're not familiar with what JCache or JSR 107 are, basically it's just a standard for caching. And the idea with it is, think of it like JPA, but for caching. If that still doesn't mean anything, just think of it as an abstract API for caching, so that you could take EHCache or Redis or Memcached or whatever, and you put these different systems underneath that API and swap them out. So now, again, right now today in Sakai 10, the only system we supported, because we're a little bit of a, again, even more of a side note, I sort of held up the Sakai 10 release a little bit, trying to get this stuff in, but I felt like it was an important thing, and the community generally agreed. So we only had time to put an implementation in there. But in the future, people could put in more implementations, right? So it might be a matter in the future that you would just say, we're using Memcache on our campus, so I'll enable Memcache, I'll put a few keys and where the server is, and boom, my distributed cache goes through Memcache.
So if someone were to stay up all night writing an implementation, I mean, what's your dream of what they would create by tomorrow?
First, I would say don't stay up all night, but I would say Redis actually probably, or Redis or Hazelcast. It's a really close toss-up. One of those two would probably be my top choice. Though I actually we use Memcached a lot as well, so it's tricky. But I guess if we want to be closest to our Apereo brethren, which we all know and love, then Hazelcast would probably be the first one, just because that's what some of the other Apereo projects are using. But Redis has a lot of buzz. Memcache has been around forever and very solid. So, but the idea is that JCache, with the way it's built, and I should say also, just side note this a slight bit more, that we actually had to make some substantial changes to the caching APIs. Not that very many people are likely to actually go on into the guts of Sakai and mess with the key caches or mess with the APIs, but just be aware that going from 2.9 to 10, there is actually some substantial changes in those APIs. So for those of you who may have been doing caching out in an individual tool, let's just say a customized tool, you may see a little bit of breakage between 2.9 and 10, but that'll be in the release notes. All right, so back to the main presentation. What did I think I covered all this, didn't I? Yes. Okay. Oh, the one thing I want to the one thing I want to mention also is that the hardest part of all of this was JSF. So we actually had to put a special hook in for that. Now that part has not made it back into the community yet because it's very difficult and we haven't fully tested that piece. But the idea is that with JSF, they have a certain amount of state within the tool itself, and that state needs to actually be transitioned to the server with the user. Otherwise, when they land in that JSF tool, it just says, I don't know where you are, who you are, whatever, I'm putting you back at the front. And so obviously, if you're in the middle of a Samigo quiz, that would be really disappointing if suddenly you pop back to the beginning and it says, please start your quiz. As a student, you may be disappointed. So there's some work that we did to start this. And I do want to point out that this aspect will keep you from losing your session. You won't have to log in again. For certain tools, it'll just work perfectly. But for the JSF tools, we only did this for one of the JSF tools for Samigo, and again, that work has not been fully tested yet, so it's not out in the community. But there is also, other JSF tools. There are also other velocity tools, some of the Wicked tools, for example, where they have a lot of session state. And unfortunately, it's just going to have to be a bit of slogging through them and doing some work to determine what has to be transferred over. That's TBD kind of thing. So,
I have a question.
So this will work, but there is additional work. Yes?
Where can we get the list of tools that was already, this was tested against, and all looks good. So where can we get the list of those?
That's a good question.
There we go.
I mean, yeah, I mean, as far as like the one piece that we have built, but it hadn't fully tested, I mean, really that's just Samigo. All the other pieces, I mean, we set up the architecture, and the architecture is there in 10, and there are certain tools that just have 0 state. They just don't have any. Like any RSF tool has basically no state in the session, when I say that. It's all request state, so therefore it just works because there's nothing to transfer between server A and server B. It's in the URL already. But for any tool that has state, yeah, that's so. Unfortunately, where we got with the project was we got Samigo done, but not fully tested. So essentially, if this tool happens to not have any state, it'll work. Otherwise, it will not at this stage.
Thank you.
So that's the TBD, the part where the community could jump in and get involved. Okay, so implementation. This is the demo, right? No, keep going there. Sorry, I forgot what our structure, our presentation looks like. Okay, so for distributed caches, right. So Terracotta, this is also a bit of a ugly thing about Terracotta. We had to use version 3.7.6. It's not actually the current version. In fact, it's fairly far from the current version, about 1.5 years away from the current version. But that's what we had to use to be compatible with EH cache in Sakai. It's also what we had to do to have it still be free.
Actually, I think 3.7.6 is the latest Terracotta. They moved to big memory.
Right. Terracotta is now called Big Memory Max.
Yeah. So we had to use the latest, which is 3.7.6, which actually Sakai EH cache. We could actually go to a later version of that, but EH cache 2.6.6 only works with Terracotta 3.7.6. So you have to version match Terracotta with your EH cache.
It's a little bit of a pain.
So you're stuck with one version of Terracotta with one version of EH cache. So,
yeah, definitely.
So if we ever need to upgrade EH cache in Sakai,
then Terracotta becomes a real problem very quickly, unfortunately. So that was a bit of an issue. We use 2 or more servers in a mirrored group for failover. I think generally speaking, we would recommend that for any production, absolutely. We certainly have used groups as large as 5 servers in the mirrored group, so that would probably be for a very large installation. I would just say if you're a smaller university, say 25, 50,000 students, I think you can get by with just 2 servers. If you're closer to 100,000, probably 1 through 4. Sky Cache Manager Factory Bean, that's actually a new thing that we added. It just replaces the default EH Cache Manager Bean. Again, these are going to be names that won't mean anything, but just suffice it to say that this is an out-of-the-box class, and this is a class that we made that extends the out-of-the-box class and lets us do some stuff that we needed to do.
Yeah,
No, go ahead.
I was going to say, basically what it does is on startup, it checks to see, do you want to use the distributed cache? If yes, is there a Terracotta, in this case, Terracotta server running at the port and URL specified? Yes. If so, okay, cool. I'm going to set up all the distributed caching stuff. If one of those conditions fails, it defaults back to the old way of doing it, the non-distributed. It just puts some logic in there to check to see if Terracotta is actually up and running and if you want to use distributed caching.
Right, exactly. The other thing I'll mention just briefly on that is that it gives us a hook, essentially, into that. So if we need to add more configuration options in the future or make things more controllable, we can.
Yeah, that's pretty much it.
Yeah.
And then you probably can't.
You won't be able to read
Actually,
this. Oh, well, maybe we can. Maybe the people in the front. So essentially, this is just a sample of the properties it would take to take a Sakai 10 instance and turn on all the things that we just talked about. It's not very much. That's the point of showing this. I mean, I know you can't read it. Don't worry about that. We've got documentation. But just be aware that it's not rocket science, right? This is what you would, if you're in Sakai 10, you should just be pasting some settings in. Again, you have to set up that Terracotta server. But you paste in some settings with your different Terracotta server URLs, however many you have, your various clustered caches and things of that kind of nature, and then good to go.
Yeah, these are in default.
Right, they're in the default
properties.
properties file that's distributed with Sakai.
Yeah, and there's more. Oh, sorry, there are more comments and stuff in there. I just kind of limited it to get to one slide, so it's more document.
Yeah, don't worry about that too much. Yeah, actually, so this is just a brief comment. Again, a little bit of gobbledygook down in the guts, but essentially what we ran into, this is one of the things I mentioned earlier, but you can't just put any random thing into the cache and make it distributed. So there are a lot of caches in Sakai that simply cannot be distributed. Primarily, it's because the class in the actual cache is not located in a class loader that's generally accessible. The Terakata's class loader really can only access stuff in shared common or server. So if there's something that's sitting inside of a component and you take that object and stick it into a distributed cache, it'll work on that server, but if you try to reconstitute it on another server, it'll just blow up. Say class cast failure. I don't know how to deal with that class because I don't know what it is. Again, because the Terakata, the EH cache piece that's running that has no idea what that class is. So you can't just go in and flip on any single cache and just say, make every single cache in my entire system distributed. Unfortunately, there's a bit of work that has to be done. So we did do some work to turn some caches from impossible to distribute to distributable, but not all of them, so just be aware of that. Yep, oh, so this is the process for doing it. The short version is that you lift the location of the class, right? Move it from wherever it is up into shared typically is the easiest solution. So.
Yeah, basically like say for events, we took the base event class, which was in it was a private interclass. It was a private
interclass deep inside of a secondary implementation.
Yeah, it was a private interclass. So we just moved it up into the API and created a simple event class.
Surfaced it as simple event.
Yes,
distributed that.
So just an example of
that's a trivial amount of work. I should say that's like a day of work. So it's not. We're not talking about a huge amount of effort to do something like that. But, oh yeah, the events cache.
Yeah, this was like the major thing that we did. The first thing we did was the events cache because a lot of the work that we did afterwards kind of related to the events and things like that. So
that was the first cache.
Yeah.
It's a big one, but it's very, very fast. All our testing shows that it was very fast.
So yeah, it's until it's like it showed. I have a graph or something.
Yeah, something there. That's easier. Yeah. So like this graph shows, essentially the events propagate out onto the cache, and you ping essentially from the servers back to the cache, pull those simple events and reconstitute. There is a bit of code underneath that reconstitutes it, but don't worry about that so much. We tend to call that rebuilding.
Yeah. The events was actually pretty simple to actually get working because pretty much everything in the events, in the simple event object, or the base event object was serializable to begin with, so we didn't really have to do any weird, like crazy things to get it to, get it up to the Terakata server.
So I think we only have like 2 minutes, so let's like skip to, well, can we skip ahead?
Yeah.
Probably.
Session
That we talked about,
Yeah.
sort of.
Yeah, just sessions, taking things out of the session, the primitives, the saved serialized.
Right. If you look in the code, you'll see there's a rebuilding service, a rebuild breakdown service. So that's just a term that we kind of made up for how this works. So essentially, breaking it down is converting the session into the smallest bits. Like I was saying before about a profile, but we don't really need all the profile data, we just need the ID. So we'll break it down to the smallest possible pieces, and then send that out. And when we rebuild it, we take those small pieces, turn them back into the big, full profile, full session, whatever.
And then basically the reverse.
Yeah,
like that session map that you cache, and you're reconstituting the session.
Right, so they're the rebuilding part. So it's breaking it down to convert it to that little piece, storing it, and then rebuilding from that little piece into the fully fleshed out session. All right, do it.
Let's see. Actually, I should probably go faster. Go ahead. Okay, I just wanted to demo what we've done real quick with like events and whatnot, since we don't have a lot of time to get into what we've done. I just wanted to show you guys. I do have I have 2 Tomcats. There you go. Here's my status. Just want to show you I have 2 Scaling 1 and Scaling 2 Tomcats. Whatnot. They're both up. I have a one of these Terracotta admin console. I just want to show you I have two Terracotta admins or two Terracotta servers working in an active passive mirror group. So one's active, one's sitting behind it, just in case the active one fails. The passive one will become the active. Yada yada yada. So the Terracotta developer console is pretty cool to see what objects and everything that you have in there, graphs and everything. And hopefully I'm on two different servers here. Yep, scaling 2. And scaling 1, right? Yes. All right. Cool. Good. You gave me scaling 1 and scaling 2. Oh, sorry.
Take our word for it, as it were.
Yeah. So yeah. There you go. You can see he's scaling. Yep, scaling 1. Okay. Cool. Okay. So eventually, they're both up and running. So I'm just going to go in here and log in on say scaling 1. So here, let's see. I'm just going to be. You can't really see me logging in. But essentially, just there. So I also we also created this little events tester, just a little REST API, real quick to show. Can't see everything that's on there, but basically this is all the session data that was stored in the Terracotta server. Basically, it's a duplicate of what is stored in the database. Except now each one of these is stored, each row is stored on the Terracotta server. And this is on the first server, and then I just want to show you that the second server, if we run it, it's the same data. Correct. Gosh, you can't really read that.
Yeah, it's very small. I can't read it.
Sorry, it's really small. It's the exact same. You can see scaling 1 is the server. Now if I go to scaling 2 server and log in, that's it. And if I refresh this, there it is. And our purge is set to like 30 seconds or something like that. So it just all purged all that stuff. Now you can see scaling 2 the stuff. And that's essentially what you want to do is you want to set your cache expiration for the events relatively short. It doesn't have to be any more than like 30 seconds because there is a process in Tomcat that runs every, I believe it's 3 or 5 seconds.
Right. You can actually ratchet that down even lower.
Yeah.
Because Terracotta can handle heavy load. So if you want to drop it to like 1 second, no problem. Terracotta can handle it. And not just Terracotta, but most of your distributed cache.
Yeah. And it's really hard to see here, but you can see the transactions per second. You can see that it actually wrote to the database and the flush rate, everything like that, not the amount of objects. It's been running for a while. But yeah, you can see it did actually hit the Terracotta server, sent the objects, up there and stored them. So, since we don't really have a lot of time, that's pretty much it.
Kill one.
Kill one? All right. Let's kill him. Let's kill the active one. So you can see that. Yeah, you can see active. An active node. So I'm going to kill the active node, and the passive node should take over. Yep, you can see it's doing it right now. It says, oh, this one left the cluster. So here you go. Now this one has become now this one's active, and it should. Well, all the event stuff has gone off.
We're all flushed by now.
Yeah, it's all been flushed by now. But take my word, it would still have all the data since it's not a mirror group. Mirror groups just simply mean all the servers in that group have the same data. So.
Also kill it as a Sakai node if you wanted to.
Yeah, you can kill a Sakai node. It'd be fine. It's just. One that would be that scaling.
That text is easy to see, I'm sure.
Oh, I know, yeah.
Make sure that's not one of your customers' nodes.
This is all just running a little bit on his laptop.
Yeah, this is all locally on my laptop. Oh no, I just killed him.
We assumed that the network here would be so bad that it was could even do command line.
Yeah, so. So yeah, you can see.
So go hit refresh in one of your browsers.
Yeah, exactly. So we're going to terminate one of the servers and then go over to just refresh. You can find the right.
Yeah, no. Well, everything's so huge on my laptop. I'm not used to everything. So yeah, you can see it's scaling too.
Do you end up back on the gateway?
No. Oh, I know. Oh shoot, that's right. Because I didn't know.
You weren't really.
Yeah, why am I back on the?
Oh, because you don't have a load balancer, because you have it running on one on
Wait, did
local
you not
host
have
and
the
188,
Apereo?
so you
Yeah,
can't really
yeah.
show the,
I'm
you
looking
can't
at
really
this.
show the refresh. You can't really show the session failover because you don't have a load balancer.
Oh, he does.
thought-
Yeah, I'm on JK.
Oh.
Yeah, I'm on
He
JK.
showed his EJB.
Oh, okay.
Yeah, does it still have both nodes or what's it show?
It's
As is typical, well,
yeah. Well, you know, demos,
typical
right?
demo problem, but.
Okay, yeah. One is out now, so but yeah.
When it's out, it should transfer the
Yeah.
admin user across automatically.
Yeah, it's done.
Do it. Yeah, whatever. Typical, of course.
Yeah, of course not.
Anyway, try.
It did work. I swear to God, it did work.
It's okay. Typical demo problems. So I think we're basically or we're past out of time. So I apologize. We ran slightly over, but I hope it was useful information. Like I said, this is all stuff that is out in the community of Sakai 10, and we welcome people trying it, testing it, and any feedback. And if you want to get involved and help with sort of adding in some additional tools, support for additional tools, that would be awesome. Sorry, please come up and ask any questions
Yeah.
after
Yeah.
afterward, but we're going to cut it
We're
here.
done. Yeah.
Thank you.